Section 8.2 is on the Pythagorean Theorem and its converse. The Pythagorean Theorem says that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. So, given right triangle ABC, we have right angle C and acute angles A and B. Notice that we name the side opposite the angle with the lowercase version of the same letter. So the side opposite angle A is little a, the side opposite angle B is little b, and the side opposite the right angle, which is C, is little c. So when we're using the Pythagorean Theorem, the two legs, that is the two sides that are perpendicular to each other that form the right angle, we call them A and B, and they're really kind of interchangeable. It doesn't matter which one's A or which one's B. But C, large C, capital C, is always the right angle, and little c is always the length of the hypotenuse. And I'm sure you've heard before, a squared plus b squared equals c squared. Square one leg, square the other leg, add them together, and that's equal to the square of the hypotenuse. Now the converse of the Pythagorean theorem says if the sum of the squares of the lengths of the two shorter sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. In other words, if the two, well, I guess you could say if a squared plus b squared equals c squared, where c is the longest side, then it is a right triangle. So the Pythagorean theorem starts with, its given is, it is a right triangle, therefore this relationship exists between the sides. The converse says, if this relationship exists between the sides, then it is a right triangle. A Pythagorean triple is a set of three non-zero whole numbers that satisfy the Pythagorean theorem. A squared plus b squared equals c squared. So, non-zero, so they can't be zero because that wouldn't make sense to have the length of a side of a triangle be zero. And they have to be whole numbers, so no fractions, no square roots, whole positive numbers. So the most common example is a 3, 4, 5. So if one leg is 3 and the other leg is 4, the hypotenuse is always 5. 5, 12, 13 is another common one. 8, 15, 17, 7, 24, 25. And there's all sorts of additional Pythagorean triples that exist. And you can also multiply these. So 3, 4, 5, if you multiply it by 2, it becomes a 6, 8, 10. And that would also be a right triangle. We have a couple Pythagorean inequality theorems. The first one says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. In other words, if your longest side of a triangle squared is less than the other two sides squared and added together, then it's going to be an acute triangle. In other words, the longest side, C here, if that's less than these two squared and added, then this is going to be an acute angle and not a right angle, and you have an acute triangle. The other theorem says if the square of the length of the longest side is greater than the sum of the squares of the other two sides, then the triangle is obtuse. So if the longest side squared is greater than the two shorter sides squared and added together, then it's obtuse. So this angle C here is not a right angle. It's actually going to be an obtuse angle, and this makes it an obtuse triangle. So let's try some examples here. Here we have a triangle that has a right triangle. One leg is x, the other leg is 9, the hypotenuse is 15, and we need to find x. So we're going to use the Pythagorean theorem. I'll go ahead and label these. I'll call this one A, this one B, and this one C. And remember, A and B are interchangeable. So a squared plus b squared equals c squared. C must be the hypotenuse. So 9 squared plus x squared equals 15 squared, or 81 plus x squared equals 225. Subtracting 81 from both sides, I get 144. and then taking the square root of both sides, I get x equals 12. And that's the length of the vertical leg of this right triangle. This example says, determine whether the set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, obtuse, or right. So if you recall from back, I think it was in chapter 5, we could tell if three numbers represented the lengths of the sides of the triangle if the two smaller ones added together were greater than the third one. So, is 4 plus 12 greater than 14? Indeed it is, because 4 plus 12 is 16. So yes, this is a triangle. Now we need to determine if it's an acute triangle, obtuse triangle, or right triangle. So let's try it in the Pythagorean theorem. So the longest side is 14, so that would be equivalent to my C. So is 14 squared equal to 4 squared plus 12 squared? If it is, then it's a right triangle. 14 squared is 196. 4 squared is 16. 12 squared is 144. And this is 196. And 16 plus 144 is 160. So no, it is not a right triangle. Okay. And taking it one step further, 196 is greater than 160, so C squared, so the longest side squared is greater than the other two squared and added together. Therefore, this is an obtuse triangle. And our last example here gives us coordinates for the vertices of triangle XYZ and asks us to tell whether it is acute, obtuse, or right. So the first thing we need to do is to find the length of each side of this triangle. So using the distance formula, and you can do this with the program in your calculator, determine that the length of XY is the square root of 8, which is approximately 2.8. The square root of YZ, the length of YZ is the square root of 2, which is approximately 1.4. And the length of XZ is the square root of 10, which is approximately 3.2. Now normally I usually stick just to the square roots because those are exact and I like having exact numbers. But in order to determine, in case I had a combination of square roots and whole numbers, I turned these into decimals, approximation, so that I could determine which one is going to be the longest side. So this one here, XZ, has to be my C in the formula. So, is a squared plus b squared equal to c squared? And it doesn't matter which one's a or b of my two shorter sides. And I'm going to leave these as square roots. Is the square root of 8 squared plus the square root of 2 squared equal to, and remember c has to be square root of 10 because that's the longest, the square root of 10 squared. Well, the square root of 8 squared is 8, square root of 2 squared is 2, and the square root of 10 is 10. And yes, 8 plus 2 is equal to 10. It works in the Pythagorean theorem. Therefore, it is a right triangle.